Okay, so if you remember, first derivative test is to see where a function is increasing and decreasing, right? When the function, when the derivative is positive, it's increasing. When the derivative is negative, it's decreasing. When the derivative is zero, that was either a maximum or a minimum. Okay. So now we have the second derivative test. So what does that tell us? That tells us concavity. Concavity is concave up and concave down. So I have two pictures here. The one on the left is concave up, what we consider concave up, kind of holds water. The idea of it, like something that holds water, concave up. So when we talk about concave up, I mean something that kind of is able to hold water. The opposite is concave down, spills water. Okay, so that's what this that's what the second derivative test will tell us. Is the function concave up or concave down? Which one does it fit? Okay. It works the same way that the first derivative test is. If the second derivative is positive, it's concave up. If the second derivative is negative, concave down. If the second derivative is zero, it's neither concave up or concave down. It's what we call an inflection point. Okay, so let me tell you let me scroll down here what inflection point is. Okay, so the inflection point is the point at which it changes from one to the other. Changes from one to the other. So this picture, there's a couple pictures here. Okay, so let me show you on the first one. Okay, so on the first one, I'll highlight it here. So where it's green, that would be considered concave down, even though, so concave down. It's considered concave down because it most resembles this guy here. So it's kind of like this portion of it, okay? Kind of curving downwards. That's what concave down is. So that part is concave down. And then after that dot, it's concave up, curved upwards, right? Well, at that dot, that's where they switch. So we call that an inflection point. So anywhere where they switch concavity, it's called an inflection point. Okay? Same thing at the opposite. So concave up here, concave down here. They switch at that inflection point. So an inflection point is where they switch concavity. We used critical value. Remember, we used for first derivative test, we used the words critical values. We still have critical values. For the first derivative test, critical values told us where it switches from increasing to decreasing, or from decreasing to increasing, which creates a maximum or minimum. For second derivative, it's going to create what's called an inflection point. Changes from concave up to concave down, or from concave down to concave up. It changes. There's a change there. Okay? So that's what because it's going to ask you, find the inflection points. That's the same thing as a critical value, but for the second derivative. Okay? Okay, so here's a couple more pictures to kind of give you an idea of what concave up and concave down looks like. So concave down, it's this idea of spilling water versus holding water. I know a lot of these, this one might be able to hold water because it's kind of a cup. This one can't really hold water because it would just spill off. But just the idea of, is it a cup? What side is the cup? Is the cup up, or is the cup upside down? So is the cup, like are you holding a cup so you can drink out of it, or are you holding a cup upside down so that it spills? Okay. So that's what concavity is. Okay. Okay. All right, so it's going to function a lot like we did in the first derivative test. The only difference is we're looking at not first derivatives, we're looking at second derivatives. Okay, so let's go to the next page. Example number 1. Okay, all right. So they want us to find intervals of concave up, concave down, and any inflection points. So it's kind of like find intervals of increasing, decreasing, and any relative maximum or minimum, right? It's the same thing, but instead of the first derivative, we're doing it for the second derivative. So the first thing we have to do is find the second derivative, okay? Well, to do that, we have to find the first derivative. So the first derivative, we're just going to use power rule, 3x squared minus 6x. The derivative for 3 is just 0. We use the first derivative when we want to know about increasing or decreasing or relative maximum minimums. It's not asking us for that. It's asking us for concavity. So we're going to skip that one and go right to the second derivative. So the second derivative is 6x minus 6. Okay. So when we wanted to find critical values for the first derivative, what did we do after we found the derivative? Set it equal to 0. We're going to do the same thing. Set it equal to 0. Okay. It's a binomial. So first we look for a GCF. It's got a GCF 6. Can divide by 6. So we get x minus 1. Set 6 equal to 0. Set x minus 1 equal to 0. And we get our answers. So I get x equals 1. 0 does not equal 6, so it's not going to give me any answers. That one's not going to give me any answers. If it was 6x, I could divide by 6, but there is no x. So this is my critical value, also known as an inflection point. Okay. So that means at 1, when x equals 1, it's going to change concavity. Now, is it going to change from concave up to concave down, or concave up, or the opposite, reverse? We don't know. How do we figure it out? Well, we're going to do our number line. Our number line just like we did for our first derivative test. We put any critical values in there. I only got 1, positive 1. We're going to do the same thing that we did for first derivative test, except this is the second derivative test. So I'm going to plug it into the second derivative. Pick a number bigger than 1, pick a number smaller than 1. I'll pick 0 since 0 is a nice number to use. I'm plugging it into the second derivative since it's the second derivative test. All I care about is if I'm getting a positive or a negative number. I don't care what the value is. I just want to know if it's positive or negative. So when I plug in 0, I get negative 6. So that means it's negative less than 0. Less than 1 is negative. It's going to have a negative second derivative. Okay, now pick a number bigger than 1. 2, 3, 10, 100, whatever number you want, as long as it's bigger than 1. Plug it into the second derivative. 6 times 2 minus 6, that's 12 minus 6, which is positive 6. Again, I don't care about I don't care about the actual number. I just want to know if it's positive or negative. So positive. Okay. So anywhere less than 1, So for the original function, less than 1, it's going to be concave down. It's going to have some version of that. After 1, it's going to come back up. It's going to be concave up. 1 is significant because that's where it changes. That's called an inflection point. It's an inflection point that changes concavity. Okay, so we're going to say concave up from 1 to positive infinity, concave down from negative infinity to positive 1, and then inflection points at 1 comma, how do I get the y value that goes with 1? Plug it into the original. Yeah, plug it into the original. So when I plug in 1 back to the original, I get 1 minus 3 plus 3. So positive 1. There we go. Okay. We know where it's concave up. We know where it's concave down. We know where the inflection point is. Oops. No. Let me graph this real quick and show you. So you can see, not on your phones, up here. Thank you. You can see, let me bold this. This is concave down. This is concave up. Where does it change? Right there. That dot right there. That dot right there is where it changes concave up to concave down. Everywhere before that point, so over here, it's spilling water. Everywhere here, it's holding water. This is the original. So without looking at the original, without graphing the original, you can tell that by using the second derivative test. Okay? Okay. That's essentially the second derivative test. Okay? Now, the functions are going to be different. This one's a rational expression. It's got a denominator, but essentially we're doing the same steps. Okay? So the hard part today is finding the derivative. You've been doing that since early September. Okay? That's the hard part, finding the derivative. Because some of these guys, these aren't too bad. That one's got an E, things like that, sine and cosine. So the hard part about this isn't using the first derivative test, it's finding the derivative. And that's why we start with finding the derivative. That's why we do a whole unit on finding the derivative. We start in September. Okay? So the first thing I want you to do, since we're dealing with concave up or concave down and inflection points, find the second derivative. Go. Find the second derivative. Tell me what the second derivative is going to be. That part you should already know how to do because you've done it on Homeworks, tests, quizzes, notes? Just simplify it as far as you can. If you make mistakes, oh well, it's notes, but it's good practice because looking at our last test, we could use some more practice on product rule and quotient rule. That was the mistakes. Those are mistakes that were made quite a bit on the last test. The only way to get better is by practicing. And if you're right now, you're just practicing. After I found the first derivative, negative 8x over x squared plus 3 squared, I did quotient rule again. Low times the derivative of the high minus the high times the derivative of the low over the low squared. Well, the low was squared already. So if I square a square, that's just to the fourth power. So that's how I get the bottom to the fourth power. If you square something that's already squared, that's just to the fourth power. So after I combine some like terms, distributed property, I multiplied these guys together to make negative 32. This is what I got. Negative 8 times x squared plus 3 squared plus 32x to the fourth plus 96x squared. And then the bottom was just x squared plus 3 to the fourth power. There's different ways to simplify it, but essentially that's what you're going to do there. So since this one has a numerator and a denominator, we're going to set each of those equal to 0. We're going to set each equal to 0. So over here, I'll set the top equal to 0, the numerator. And over here, I will set the bottom equal to 0. Those will all give me critical values. So I'll start with the right side, the bottom, because that one's not as long. So to get rid of the fourth power, you take the fourth root. The fourth root of 0 is just 0. Oops. Then I'm going to subtract 3 from both sides. I'm going to take the square root of both sides. But when I take the square root of negative 3, that's imaginary. There is no number. There is no real number that I multiply by itself to make negative 3, positive or negative. So it's not going to give me an answer. So anytime you end up with an imaginary solution, in this class, we don't worry about it. Math 3, we dealt with imaginaries. This class, we don't deal with imaginaries. We're dealing with real numbers. Okay? So that guy's not going to give me any answers that I can use. Okay? So let me go to the other guy. Oops, forgot this squared part here. Okay, so I got a lot of squareds to the fourths. So I'm going to need to, first thing I need to do, I can't distribute this negative 8. I can't distribute it because of this squared here. So I need to multiply the squared part. So I'm going to take the squared part, this part here, and I'm going to multiply it out. So I can distribute the negative 8. To do that, I'm just going to use FOIL. So when I go first, I get x to the fourth. So over here, I'm going to write it all. So x to the fourth, outer, 3x squared, inner, 3x squared. 3x squared plus 3x squared is 6x squared. Last, 3 times 3 is positive 9. Okay. So now I can distribute the negative 8 because there's no more power. So I distribute it to all 3 terms, and I get negative 8x to the 4th minus 48x squared minus 72 plus 32x to the 4th plus 96x squared. Okay, combine any like terms that you can. If I combine the x to the 4ths, I'm going to get, let's see here, x to the 4th and x to the 4th. I'm going to get 24x to the 4th. And then x squared, I'm going to get 48, positive 48x squared, and then minus 72. Okay, so now I have a trinomial. So trinomial, first thing you do, GCF. I think there's a pretty big GCF. I think 24 goes into all of them. I think 24, let's see. X to the 4th, 2x squared. And I believe it's times 3. Twenty-four times 3, 2, yeah. So I'm going to factor the trinomial. So I need the two numbers that multiply to be negative 3, but add up to be positive 2. Positive 3 and negative 1. One of them happens to be difference of squares. So it's 24x squared plus 3, x plus 1, x minus 1. Since we're solving, it doesn't really matter if you do difference of squares. You would have gotten both answers, but still. Set everything equal to 0, and we're going to get some answers. So 0 equals 24. X squared plus 3 equals 0. X plus 1 equals 0. X minus 1 equals 0. So the first one, you're not going to get an answer because 0 does not equal 24. The second one is going to give you another imaginary. How do you know? Because you already did it. We already did it over here. X squared plus 3 equals 0. We did it over here. It gave us an imaginary answer. The only two answers that you will get are from the last two. Negative 1 and positive 1. Those are critical values / inflection points. Okay. All right. Number line now. We need to check those to see if they're concave up or concave down. So -1, +1. So again, I only care to see if they're positive or negative. I don't care what type of number, what number the actual number is. Okay? So I can try second derivative -2. So I have to plug it into the second derivative. Okay, so I'm not going to actually do any work for this one because I'll show you in a second. This is the guy I would plug it into. This is the guy right here that I would plug it into. Does anyone know why I would not need? I could do this in my head. It looks pretty crazy. It looks pretty long and pretty ugly. But if I'm plugging in -2 here, because of all the powers, right? What are the powers going to do? What is the squared's going to do? Make it positive. What is to the fourth going to make it do? Make it positive, right? So I can whittle down where it's going to be positive and where it's going to be negative. So right here, if I were to plug in -2 in there, that's automatically going to become positive. It's going to become +4, right? And then this guy right here is going to become even bigger positive, right? But then when I distribute, it's going to be negative. Okay? This part here is going to be positive. This part here is going to be positive because you square it or to the fourth power and it'll just be positive. The bottom will be positive as well. Okay? So the only part I have to worry about is this part here. That part there. Okay? So when I square -2, so when you square -2, you're going to get 4. Plus 3, 7. Squared, 49. 49 times 8 is roughly, -8 is roughly 400, -400. Roughly -400. Not exactly, but roughly -3 something. Okay. So when I plug in -2 here and -2 here, it's going to multiply with these guys. So this is going to become +16. So 32 times 16 and 96 times 4. So let's see, 96 times 4 is, that one's going to be over, it's going to be 370 something, 374. Plus this guy here is going to be over 400. This guy here is about -400. So the top is going to be positive. So a positive divided by a positive will make a positive. Zero is nice because when you plug in 0, everything goes away. So I'm going to plug in 0. Let me go back. So when I plug in 0, that's going to go away. That's going to go away. Not worried about the bottom because it's just going to be positive. This won't go away though. This will become 3 squared, which is 9 times 8, which is -72. So the top will just be -72. The bottom will be positive. So the whole thing is negative. Last one. Since I plugged in -2, let's plug in +2. Is there going to be any difference between plugging in a -2 to a +2 to this guy here? What's the difference between plugging in a -2 and a +2 to this guy here? It's not going to be any difference. Negative 2 and positive 2 squared is still 4. Negative 2 and positive 2 to the fourth is still 16. Negative 2 squared is 4. Negative 2 squared is 4. So it's going to be the same answer as I got with negative 2. Okay. So concave up before negative 1, concave down between negative 1 and 1, and then concave up back again. It's going to kind of look like a W. The graph is kind of look like a W kind of graph. And that's what x to the fourth graph looked like. So we say concave up, negative infinity to negative 1, or 1 to positive infinity. Concave down from negative 1 to positive 1. Inflection points at negative 1 comma something, 1 comma something. So we just got to, all the last thing to do is plug in negative 1 and positive 1 back into the original, but the original wasn't that bad. So when I plug in negative 1 or positive 1 to the original, I get 4 over negative 1 squared plus 3, 4 over positive 1 squared plus 3. You're going to get the same answer. 4 over 4, which is 1. 4 over 4, which is 1. So negative 1 comma 1, positive 1 comma positive 1 comma positive 1, and you are done. Like I said, the hardest part about these guys is finding the derivative and then finding the second derivative. That's why we do it before we do this chapter, because you've had practice in it. Now, are you perfect at it? No, of course not. I don't expect you to be perfect, but I expect you to at least have a better understanding now than you did last chapter. Okay, this chapter will build your skills for doing it next chapter, so that by the time we get to next semester, oh, derivative, okay, I can do it. You know, finding derivatives, especially if it's like this, it's not the most clean thing, but you can do it, right? You might have to take your time, and it might take you 5, 10, 15 minutes to do it, but you can at least do it, right? It's something you can do. That's what I'm looking for. Okay. All right. Okay, last thing we're going to do today is, okay, so the next type of question they're going to ask you is they want you to combine the first derivative test with the second derivative test. So this is the second thing they want you to do. So they're going to say, okay, tell me where this function is decreasing. First derivative test, we did that last week. And also concave up. This week, today, what we're doing now. So mixing them. So it's nothing you haven't done, but it's just mixing them together. So how are we going to do this problem? Exactly, we're going to start with where is it decreasing? Where is it decreasing? So how do I figure out where it's decreasing? First derivative, let's do that. This function isn't so bad. Doesn't have a numerator, denominator, doesn't have roots, doesn't have things like that. So it shouldn't take us that long. So let's do that. Find where it's decreasing. That's what I want you to do right now. So the derivative, do it on your own, but I'll just kind of talk it through since I'm recording this. So the derivative is 6x, first derivative, 6x squared minus 60x plus 54. Okay, it's a trinomial, GCF. I think I could divide them all by 6. So we get x squared minus 10x plus 9. So I got to come up with the two numbers that multiply to be 9, but add up to be negative 10. Negative 1 and negative 9. Set them all equal to 0. The first guy is not going to give me an answer because there's no variable, but the second two will give me an answer. Okay. I get positive 1 and positive 9. So those will be maximum and minimums. So now we got to figure out where it's decreasing now. So we got positive 1, positive 9. So before, between, after. Check 3 places. So when you're plugging it into the first derivative, you can plug it into here, you can plug it into here, or you can plug it into here. They're all the first derivative. They're just one's factored and one's not. I would personally plug it into here because it's a lot easier math to do. You're just subtracting and then multiplying. You don't have to deal with powers and multiply times 6, multiply times 60, add 54. So work smarter, not harder. Don't necessarily have to plug it into the first part right here. These are all the same. They all say the same thing. One's just factored and one's not. Okay, so when I plug it in here, when I plug in 0 here, I get 0 minus 1 is negative 1. 0 minus 9 is negative 9. A negative times a negative makes a positive. Times positive 6, that's going to be a positive answer. This is where mental math helps you. Mental math lets you go a little faster. When I plug in 2, when I plug in 2 here, when I plug in 2 here. So when I plug in 2, I get 1 and negative 7. So 6 times 1 times negative 7 is going to be a negative number. There's my decreasing. Plug in 10. 10. 10. 10 minus 1 is 9. 10 minus 9 is 1 times 6. Positive number. So I know it's decreasing between 1 and 9. So I don't care less than 1. I don't care greater than 9. I'm focused on 1 to 9. That's where it's decreasing. Now let me find where it's concave up. Second derivative. So the derivative of the first derivative is going to be 12x minus 60. Because I just found the derivative of this guy here. Set it equal to 0. I'm going to add 60 to both sides. Or it's a binomial. You could do it that way, but since it doesn't have a squared or anything, I'm just going to do it this way. You could divide them both by 12 and do it that way, but I'm just going to set 12 equal by itself. Divide by 12, and you're going to get x equals 5. That's a critical value, also known as inflection point. Last step, figure out, okay, so it's either concave up before 5, or concave down before 5, and then the opposite after 5, right? So we want to figure out. Okay, so I'm going to plug in, I'm going to plug in 0 for a number before 5, because 0 is nice. So 12 times 0 minus 60 is going to be negative 60. That's a negative number. Plug in a number bigger than 5. I'm not going to plug in 6. I'm going to plug in 10 because 10s are easier to multiply by. You could multiply by 6, but I'd rather multiply 12 times 10 than 12 times 6, because 12 times 10 is just 120. That's positive 60. Okay, so now I have all the information I need. I just need to answer the question. We know where it's we know where it's decreasing, right? It's decreasing from 1 to 9. We know where it's concave up. From 5 to infinity. Where do they overlap? Where does the bottom number line overlap with the top number line? So if I was to do this, 5 goes right in the middle here. Where are they double shaded? From 5 to 9. From 5 to 9. That's my answer. F of x is both decreasing and concave up from 5 to 9. From 5 to 9, because that's where they overlap. The minuses and the pluses, the minuses on the top number line overlap with the pluses on the bottom number line from 5 to 9. I'm done. Those questions are very popular on tests because it talks about both the first derivative test and the second derivative test. So it's a way of getting one question hitting two things with one question. Those are big. Those are popular. I've seen those on multiple choice and free response questions. Those questions there. Okay. All right.